and on a state project and developing that. Okay, where do we start here?
Corey, I teach in Bronx Middle School for Writers and Artists. My name is Celeste, Brooklyn Generation School.
Diane, Lincoln High School.
Francine, Brooklyn School for Collaborative Studies.
Allison, Brooklyn School of Collaborative Studies.
Liz, CUNY.
Andrea, Richmond Hill High School.
Leo, Beacon High School. Samuel Haver, Trinity Art High School, Bronx.
Francis, Brooklyn Theater Arts High School.
Katrina, Queens High School of Teaching.
I'm Jeanette Perdomo from Marlborough School for International Studies, and I just found out yesterday I'm teaching this class.
Yes, excellent. All right.
Deanna, Esperanza Preparatory Academy, East Hartford.
Raina Joa, Brooklyn High School of the Arts.
Tim Gamson, Bronx High School for Law.
Thank you. Okay, welcome. It's a pleasure to have you all here. It's also great to see some returning faces, and yeah, it's an interesting challenge. We know that people have dealt with not necessarily, you might like to have your materials in June rather than September 15th or something. Sometimes can be what it feels like you're dealing with. So here's just a little picture of our plan for today. We're gonna be, no, we don't get to fly you to the Amazon, but it's the next best thing. So a little topic, math in the Amazon is actually coming from one of the algebra branches, but we're kind of exposing you today to some of the algebra and then also focusing on the proportional reasoning material. So after that, we're going to do some work kind of asking you to also be sharing your own professional work with colleagues. Then, let's see, we're going to be just talking about some business around help with trying to set up some visits and things. After lunch, we're going to, again, some kind of business and handing out what we see as kind of some recommended pacing guides. They're not strict beyond this section this day, but there is a suggestion that, whenever you have your test coming up, you probably want to be through this through the first almost 3 chunks of algebra, right? So we'll talk a little bit about some pacing and calendars at that point. We're going to spend some time talking about some ideas for Compass test prep. And again, this could be an opportunity. Some of you have been doing this for a few years. Some of it may be new to this, and you're more familiar with Regents exams. So we'll get a chance to kind of look into that. And we're also going to be doing what we call a non-routine problem, right? So some of you who were with us before, we did the sums of consecutive numbers problem. It could be interesting for us to later maybe hear how some of that might have gone for you. And then if we have a little more time, we're also going to step back into a little bit more with the algebra material, okay? Okay, so that's our plan for today. So where are we starting? Math in the Amazon. I don't know, I kind of freaked out. Okay, so here's a warm-up. You can kind of jot down answers for
And so
you.
there's actually scrap and pencils on each table in case you'd like.
Okay, and just take a couple seconds to...
Is this in the workbook already?
No,
Okay.
no.
Yes.
That question was, is this in the workbook? And the answer was no. What you'll find is often warm-ups and exit problems are not being set for you. Okay. Once in a while they're there. Once in a while, but I think it gets, yeah. Okay, so this is kind of a warm-up, find the lowest number from a given set. We could imagine, do students have certain kinds of struggles with problems like this? Lowest number, do they get confused because they have this idea around, absolute value, which also confuse them? There can be different things that, so this could be a 5-minute opportunity for a brief note about some number lines or something like that, right? Add the following. Do our kids struggle a bit with operations with integers? Yeah, they do, right? So one of the things that's simply put together with this warm-up is letting it not so much be about the numbers, because there's some repetition in the little digits that they're seeing, right? But what might it mean to kind of think and talk about that? Does this become a simple problem for them? Maybe that one is, and we hope so, but it's also an important idea, right? So this is just an idea for a warm-up. Now, we'll get back a little bit later into why that might have been the warm-up. Okay, so Amazon Island is this little island that's a little bit distant from Amazon, but we just called it that, okay? And this population of people has been separated from the rest of the world forever. It's just hasn't been an island that's been touched. And so they haven't been affected by the mathematics that the rest of us do as much. But they did acquire some of the same things that we do. So they kind of have their own currency, and they do trade. They do look for lowest prices when they trade, and they do sometimes buy more than one thing. Okay, so that's really what they've seen their math for at this point on this little island. Okay, although there is a little group of them that's kind of feeling excited about playing around with what they have. Okay, so here's what they've done. They developed an operation called minimize. Okay, and that operation it's a binary operation. So 4 minimize 5 would mean find the minimum between those two numbers. Okay? So there's an example. Somebody might be selling coconuts at 2 units, somebody else at 3 units. They know that the thing they always find themselves doing is finding the lowest price among those. Okay? Okay. So you can kind of see at the bottom. Now, so go ahead and, the question at the bottom, what if I wrote 9 minimize something equals 5? Turn to a partner at your table, what would that mean? What might we think about? Okay, do we all agree the answer would have to be 9? No. What's the answer supposed to be here? 5. Okay. So we used a blank to start with this introduction instead of what could I have used? I could have used a variable here, right? So that might have been a choice in the introduction as to what you might use. Okay. So they also, like I said, they also sometimes find themselves buying more things than one, and so they created an operation called join. And join is that they might be buying some watermelon at the price of 8, so they might be buying some pineapple at the price of 4, and so they use their operation join now to figure out how much of their currency they actually need. And so what do they need? We can see what they did. What is this really? All this is adding. Okay, so what about this question? What if I wrote 40 join x equals 50? What would they say? Turn to a partner, what do you got? Yeah, so I have some choices in how I might whether I want to use a variable or whether I want to use something like an empty something, right, for them to fill in, right? What if I wrote, now here's one that they got kind of excited about. 12 minimized k equals 12. Turn to a partner. What would that mean? 12 minimized k equals 12. Okay, I'm gonna let that hang. You as math teachers probably got that, but we might want to think about how we push our kids to think about that for a minute. Okay, so there's a little group of these people on Amazon that are kind of excited about these symbols that they created and the conversation and the language that they've made, and so they've started just playing around with it on their Sunday afternoons. And so what we're going to do right now is you as a mathematician working for well over 10 years, thinking about your students actually, right? You're going to actually go in there and kind of help them. You're just traveling around in a boat, you found this little island, and you were able to kind of find that you could converse with them and see their symbols and figure out what they meant, so you started to kind of help them along. You're going to be the Amazon mathematician. Okay. So now what I'd like you to do is to turn to page, oh, they don't have it yet. Okay, so now we're going to pass out the algebra materials. Okay? And then what I'd like you to, can we actually ask for bigger volunteers? Thank you. Yeah, one set per person. Okay, and then turn to page 316.
We put it right into the regular one.
Oh, just one more? How are we doing over there on that side? One more? Okay, sorry.
Thank you. We have it. Yes, thank you. One over here.
Yes, I have it. Thank you.
That's right.
Okay. Who here
Bye,
has,
yeah, thank you.
who here has what we need? You all got one? Yes. Did you guys all get one?
It's becoming heavy.
I know. Okay, everybody got one? Okay, so page 316. Go ahead and turn to page. Give it into that binder, hopefully. Hey there. Here. Or there. Sorry, page 316. I'm sorry. Okay, so what I'd like you to do on page 316 is go ahead and just spend a few minutes working through those problems, okay? So activity 1 extends from 316 through 317. Go ahead and work on those. If you end up kind of with a little extra time and we haven't broken into a share yet, then you can do the stuff on the next page also. Okay? So, and yeah, we're asking you to maybe start out independently, but if you want to have a partner that you're kind of just checking with here and there. Yeah, yeah. I think in a sense, it's going to be 3 parts. You'll be getting a part 2 of 3 pretty soon. Yes, it is. It's still going through, like, it is. So but it's bigger and romantic. There's lots of, this is the first round. If you happen to be marketing, I mean, people are editing them also. So there's a good chance that you don't have to feel obligated to write down the one. But if you catch one that you feel is a bigger error and you just want to be extra sure that it gets something that's a bigger thing, then you might want to Okay, so this is new. Hi.
Should we assume that it's on
Oh.
this stuff applies? We understand.
We want to make a decision at the table, make a call on it. But yeah, I'd say, since you, some 12th grader at your school, has gone to that island and started working with them, you can kind of push that in, okay? Because that 12th grader would kind of go that way.
Yeah. No solution more.
Let's just say something.
That's why it's on
Hi. So one of the things we went with is trying to figure out what are the things that we could be. Does that work? Ah, good question. Good question, right? So you know what, you're the assistant here is, okay. So you're, the role here is that you're a 12th grader visiting the island, and so you could make a decision here. Now remember where their operation comes from. It comes from comparing two people selling them stuff. So what do you think? Like it could be that both of them are saying, I'll sell it to you for $5 and I'll sell it to you for $5. So we could still say that the minimum is $5. Okay, good question. Good question. Trey, can you just write down that question so that we'll come back to it? Okay, and like when we get to a whole class conversation, just make a note of it because I'd like us to bring that up. That's good. Okay, so what I'm asking you to kind of be doing is working all the way through number 6. Okay?
That's what you're saying. Talking about hydration or something.
Have you got your phone? Have you got your phone? Oh. You got your phone? That might help me, right?
No one was fine. Just whatever it was. I'll figure it out.
Okay, if you've worked through number 1, go ahead and make sure you kind of compare with somebody at your table. See if you agree. As questions arise, here's the note, okay? Imagine your knowledge to be the knowledge of your student, okay? And that student is the mathematical expert coming to kind of work and guide the people on this island with the creation of their mathematics, or the development of it, you could say, right? So use some different judgments that you might think about from that perspective, okay? And then you're welcome to go ahead and keep working through 2 through 6. If you want, go ahead and work with that partner. Okay? Everybody have a name tag? Everybody got a name tag on? Yeah. I should put one on. So we have an odd number of people in the room, so just make sure at this table, everybody else has an even number, so make sure that there's one group of 3 here, okay? Oh, they do? Oh, yeah. You guys need a group of 3 also, right? And we talk about these? All right. Okay.
I'm thinking like July, when we get into July. Yeah, just last week. So it should be right. Yeah, so it is on that side as well as the.
Okay, if you finish through 6, I do want to give a few more people more time, so you can turn to the next page also. Okay, if you finish through number 6. Yep. Okay, if you and your partner kind of work through that, yeah. If you're done with these, you can actually take a look at the ones on the next slide. Okay.
And that will be word by word.
You would have to go into be able to find the word document. And it's also about can't find it. Drop me an email, give me a call, let me know. If it wasn't right, then that's why we gave you now. Maybe it's hiding out.
Okay, so where might we anticipate a vocabulary word that our kids might be unfamiliar with? What might we anticipate? What? Conjecture, right? The word conjecture is a word that our kids might be unfamiliar with. I think that's a good guess, right? So let's see, what could be a guess of, or what could be a conjecture? Does anybody have a conjecture to share? Who has a conjecture to share with us? Not everybody all at once. Anything related to minimize and join. That's interesting. On any topic is interesting, right? What was a New York? There was a New York Times nice story on a math conjecture of a historical thing. Anybody read that opinion story by Manuel Suri about tessellations with pentagons? And so there had been a period up through, it might have been like 1972 or 1975, where they thought there were only, okay, I'm messing up now, but maybe they thought there were only 7 possible tessellations with pentagons. And this mother who, saw this in a Scientific American article by Martin Gardner, started just playing around with this problem, and she found 4 more. So the original conjecture might have been, there are only 7 ways to create tessellations with pentagons, okay? And it was proven false by her simply creating some examples. But the conjecture might have been a statement like, there are only 7 ways to create tessellations with pentagons, okay? So I could make a conjecture about minimize that function. Is there something what would I say? Thank you.
Well, with the minimize function, if we have the same number on both sides of the equal sign, then the number of solutions is infinite.
Oh, cool. Can you say that again a little louder?
Utilizing the minimize operation, if we have the same number on both sides of the equal sign, then the number of solutions is infinite.
Ah, that's kind of cool. Did you hear what she's saying? Okay, so that's an example of a conjecture. Okay. Anybody have another one to share? Actually, yeah.
With the minimizing symbol, order does not matter.
With the minimizing order does not matter is another conjecture. Okay, now what I'd like to do is give you another 2 or 3 minutes to think about conjectures. Okay? Take another 2 or 3 minutes right now to think about what might be another. Those are 2 beautiful conjectures that just got posted. Okay, that just got shared. Okay? Okay, but I'm going to wait. I'm giving people a little more time to think about it. You can record yours.
So then the right side of the equal sign is larger than the minimize.
Francis, can I ask you guys? You don't?
Good night. No, but she's like, yeah.
Okay, so go ahead and share with the people at your table. Go ahead and share with people at your table what might have been one or two conjectures. So go around the room, go around your table, each sharing one first. Okay, and then if somebody has another one to add, go ahead and do that. Okay, so around your table, share a conjecture that you feel like you could phrase. It doesn't matter if you've proven it's false, right? That would be okay. You may have thought about it for a minute or two and then decided it was false, but it was still a legitimate conjecture at a time, right?
It's not a specific number, but it's the same.
I just said that kind of building off of what you said, that the numbers to the right of the sign is larger than the other numbers to the left.
It's hard for me, and I didn't.
So, why don't you start with your conjecture? Well, I'll do it. Yeah, the one you just said.
I
didn't hear.
Oh, okay.
I wasn't.
I said that we step in time is on assuming that numbers have increasing numbers are bigger. 6 is bigger than 5, 7 is bigger than 4. Assume that the
But
number.
the digits are the
Yeah.
same.
As opposed to having it be different.
Okay, so that might be something that has to get defined and confirmed, right? Okay? And with this 12th grader stepping in, we could kind of say that might be something that they'll kind of confirm, right? Are you guys using the 6 the same way we are? Or are you using it as something else,
Does that would
right?
apply also for
Right, is this, what number do you write as this, right? What number do you write? Okay?
My conjecture is if the number on the right side of the equal sign is larger than the numbers on the left side, then there is no solution.
Okay.
If the number on the right is less than the number on the left, then one solution has to be chosen.
And you guys, you might want to also, so it's interesting, here's a question right now. As you share these, and you're the listener, would it have helped for there to have been a visual as the person shared? Right? So then grab something and create that visual, right? Because that'll kind of help us. Because otherwise it's actually hard. It's a slow, for me it's a slower processing of really knowing what she just said. Okay? Oh, cool. What was it?
This is lower than the value.
So looking at the,
Say it again?
so we're looking at an identity element. There's no,
Here's the conjunction.
like you're saying,
Categorize and
small numbers on
Okay.
this side, and it's
Have other
always
people shared a conjecture at this point?
but there's no identity of this number.
Alright, alright.
12,
You know, what I would say is,
See right here.
but we also
This one
talked
might be more
about
than
how do you get
They need a partner there, and they could use a partner right there. Right here? Yeah.
You have something like this, you have many circles.
Right, that's what I'm saying. So there is no identity. There's no one identity.
Okay, so sometimes as you share your conjecture, did you make it visual for your team? Is it hard for us to digest the sentence that our table mate might be giving us just audibly? So that's a question for us to kind of consider, right? The difference in digesting language when it's about mathematics. It's a slower process than if this had just been the initial story, right? Okay, so let's hear, and maybe if you can even create on a piece of paper, in your group, pick one of the conjectures that you heard and share it with us as a class, okay? So pick one of the conjectures, write it on the paper in just a symbolic whatever to help us understand what you're about to say to us, okay?
Right side of the equal sign is bigger than the left side.
Nice try. You got one? Yeah. You write something down so that write it on big colored paper so that you can kind of hold it up.
No, there isn't.
Okay.
There isn't. Multiple numbers.
I mean, when you think about what it is, it's not one thing.
I don't think about it. This is
Say
like
the
the first
impact
workshop, so I think.
the number larger than the number more than
Whenever you have a moment, no rush. Needs a pencil for the sign, it's fine. And we're just working through page 316. We've all kind of spent some time with the material already. Okay. Your team can catch you up here.
Okay, so you're making a little bit of a visual to help the rest of us capture what you're about to share with us, okay? You guys got one to share? Did you pick one to share as a table?
Not yet.
Not yet? Okay.
Your stuff that you didn't get in September, and you can just pop this other stuff in the back if you feel like.
Okay, so let's go ahead and hear somebody share a conjecture again, okay? So, who would like to start? Yeah, I'm sorry. Allison. Allison.
So the numbers to the
Show, kind of hold that up for us to see.
the numbers to the
All right above her head, right here. Okay.
If the number to the right, the equal sign is larger than either of the numbers to the left, and then there's no solution.
Okay. So when we're taking a conjecture also, this is not necessarily a place to prove it or disprove it. We're just kind of letting the conjecture be posted, right, or be shared, right? We may be proving this true or false. We might find things within it that need to be defined, or we might have questions to ask, okay? Okay, who would like to share next? Yeah, why don't we ask you to, okay. Thank you.
Choose fire, use A. If you have A minus A, then you have no solution.
A minus A, no solution. Okay, so there's a conjecture. We might have people agreeing with it, we might have people disagreeing with it, right? Our consulting staff here is a 12th grader visiting the island. And then we have a group of people on the island, right? So we could have some conversations flowing from a conjecture, right? To either prove or disprove it. Okay, how about this table?
We just did the same as the first table about if the value on the right side of the equal sign is larger than the values on the left, there are no solutions or there is no solution.
Okay, and how about this table?
It's the same as this.
Okay, so let's, you know, we could have gone into some different places. So can you raise the issue that you had raised initially? Was a question that was good question you felt like?
Yeah, I think that's what they said. If they have the two numbers, you try to minimize 5 and 5, which one would be your solution?
Okay? So we could take this problem and go back to apples. They want to sell me an apple for 5 units. They want to sell me an apple for 5 units. Am I going to walk away with an apple or no solution? Think about that. See your question. Okay? Okay, so I'm actually going to skip through a few things because as teachers we know our plans might change. Okay? And to kind of step aside, how did we use the issue around conjecture being likely a new vocabulary term? Okay? It might mean that I interrupt student work time to briefly talk about that. We had somebody share an example. We had 2 examples shared. And then it went back to work time, right? So the idea of mini sharings that might occur, not always at the end of the task or at the end of the class, right? You may find important reasons for these little mini discussions to occur at other points within the lesson, right? Should I feel obligated for all definitions needed to be at the beginning of the class, right? We were learning minimize, we were learning joy, and there was this little story about an island. Did I need to be defining conjecture there? We could have some different opinions on that, right? But I'm just kind of sharing a teacher note, right? For one choice it might be, you know what, I'm going to come back to the vocabulary of conjecture in a bit, okay? So I'm going to skip over what original share ideas have been. There was to be a conversation about a conjecture, some sharing, and test them out. How do we test out those conjectures, right? So one of the routes to take with the lesson like this is that we post some conjectures. We might need to have a little discussion to make sure everybody's clear on them. And then the task is for students to either prove or disprove them. Okay? Okay. So I'm going to ask you again to think about this question for a minute. Does Amazon Island need an order of operations? Is it going to involve Aunt Sally, Uncle John? I don't know. But so spend a few seconds thinking about that question. Okay? Do they need it? Do they need an order of operations? Prove it. Prove why they either need it or why they don't. Okay? Prove and explain why do they need it, or prove and explain why they do not. Oh, does Amazon Island need to have an order of operations? Oh, what did I just say? Let's see. Sorry.
So mine is I think the same five put those joints and then minimize operation.
Yeah, you found the way to store this people, right?
Yeah, they have that as
Why
well.
it went next, we went
Can we move into the it's a copying mistake.
Oh, okay.
And I
It's
found
a
out that
copying
it's different
mistake.
numbers.
Depending on your grouping.
Yeah, depending on how you put those orders. So that's why I believe that they need that different results. You can get different results because if you add and you find the minimize, some example of the numbers.
But you're combining operations.
I just followed this example there.
So that the first one is actually combined, and the second one is minimum. So
It's
yeah,
not saying if it's given, you find that you just one operation. I don't think so. 5 is more than 5 years. So
Oh,
because
using one,
operations
yeah, with
is
this
what I needed.
application.
Then this
Right,
is
when
where
we-
this join
Yeah, but when we talk
results.
about order of operation,
Special island, that's what they're on.
unless you choose one operation, addition, you would add everything. You want from right to left, or you want from left to right. But the only problem is subtraction.
You can also be looking at activity 3. It might give you some ideas about
This activity, talk about the misapplication, if you miss them. What are we looking at?
I think when you're talking about
So, what do you guys think? Do they need order of operations? Oh, cool. It's an example problem, right?
Yeah, would that be too?
This is the question for you, right? Like, so in other words,
Well, the issue here is that whether we're looking at this, are we looking at this and then we do the back? Because there's no parentheses or anything. This is the way it's presented. Or looking at the back, the front, and this. So then, in that case, you cannot do it one way, you might do it another way, and then move back. So we probably would need the other application.
okay.
Everybody didn't fall. For instance, it doesn't matter.
In some ways, like, with enough parentheses in the light, we wouldn't need order of operations, right?
But on the flip side of that, when it's not there, you're not sure which one to address first.
Now, let me also just point you to something coming up. So, this is, yeah, it's actually further down, and it's kind of with the idea, can we just get rid of the problem by using it as more? Okay, so it's a, yeah, but it gets really ugly, like you can look at this just and say, would you rather look at this or this? Okay, so it's an important, it's a nice idea, right?
Thank you.
I agreed with you that it was a problem. Okay.
So,
You don't know which,
like this,
why do we
you
need
gotta take
it?
everybody from the
So you don't know which operation
back. Which one we do first?
Just like if you on an island, you have some organization, you must follow some principle or some standard. So just like man, this is one set up in order for you to have some.
Everything is time of addition.
So when you see a 3 times 4, you might instead write it as?
Go back to 2 plus 1.
Repeated addition.
So they're seeing that pattern. Like if you try to bring it down for them, they understand that the addition is very impactful. I want to say a lot of multiplication. If I fall it back to addition, I'm okay. Of the division part, if I fall it back to multiplication, of the subtraction. I just say subtraction, just think about it.
Okay, so let me interrupt you a little bit.
It's more easy for them to see.
Okay, so what do you think? Do you think they need order of operations on Amazon Island? Yeah. Why? How do you explain that? Why do you think they have to have it? Because you know it's like, wow, do we really have to memorize one more thing? Is this going to be about Aunt Sally again? Is this going to be about PEMDAS? Yeah. So what do you think? Why? How can you explain, or how can kids have a conversation about why order of operations is needed, is useful, right? Okay, what do you think?
To avoid confusion, it's the one problem. If it's done different ways, we'll give you different answers.
Done in different ways, we'll give a different
Yes,
answer.
yes,
I'm just gonna say use the example on, use the example number 2, 318, and showing that if you do approach the same problem 4 different ways, if you get, a couple of different answers, that which one's the right one?
Right? Okay. Okay. We also had a conversation about, well, what if you just have parentheses? Wouldn't that be, right?
Yeah.
That's what you were suggesting. Why don't we just forget the other stuff, order of operations, and just do parentheses? What do you think?
but it's also, wouldn't it depend on where the symbol is placed? Because even if I use parentheses, if I have a joining symbol versus a minimized symbol, it's still gonna create a different answer.
Okay, can everybody hear what she's saying right now? Can you say it again?
I'll try. Even though I have the parentheses, it also depends on what symbol is there. So if I have a joining symbol versus a minimizing symbol within the parentheses, it could yield a different answer.
Yeah, what she was trying to say that I discussed with her is that within each one, you will just have the parentheses between two numbers and one symbol.
So, okay, so this is
Meaning
an
you have multiple parentheses to avoid what you just said.
Okay, so let's take a look at how this gets addressed in the curricula. So turn to page 326. Okay. So you leave the island of Amazon, you return to Florida, you get on a shuttle, and you go to the planet Krypton. Got it? Okay. So I'm gonna go ahead and just read that top paragraph on page 326. The planet Krypton is a place without order. They refuse to agree to adopt a single order of operations. The Western lefties think that order should just come from left to right. On an Eastern continent, they want to go from right to left. Those on an island without much ink and pencil lead want to reason out a logical choice that everyone on the planet follows. Others see no reason to create rules for the community to follow. Okay, so this is actually a little pointer of another activity that comes right up. This is what's kind of coming next, is a little bit more to push conversation on motivating the issues around around order of operations. Okay, so that conversation that was happening right here about parentheses, we have kind of an opportunity to kind of push kids and get them into that conversation about parentheses. So if you look at question 3 on that page, it's like, would you want to have to write all of those parentheses? Okay, because the Western lefties, if they don't adopt things like exponents before multiplication, okay, or multiplication before addition, if they don't adopt that, then when they're communicating their math, they would need that, right? Okay, so we're going to shift gears now. We're going to come back to this lesson in a little bit to just kind of talk about some planning around the lesson. But first, what we're going to do is we're going to ask you to shift gears into your own teaching, okay? So, how many of you have been teaching proportional reasoning for at least a week? Let's have you raise your hand. Okay. Okay. How many of you have not been teaching proportional reasoning for a week? Okay. Okay. So here's what we'd like you to be doing. We asked you to come with your materials, and we're going to ask you to be sharing a lesson that you recently completed. So either yesterday or Friday. Okay? We're asking you to kind of work through and talk about and share a lesson that you completed. So here is our task. Okay, I'm going to give you instructions for this share in a minute. Okay, so here's the. It's just one for 2 people. Okay, so here's what's happening. I've created a little set of questions that I'd like you to use as your share. So you're going to be making a decision to either be sharing a lesson from yesterday or hopefully a lesson from Friday. okay? Person one is going to be the interviewer first, okay? And they're gonna go through all of the questions in the packet one at a time. Okay, so they will read the question out loud, and then that person will also take a few brief notes on what the person is sharing with them, okay? Enough for you to kind of be able to recall a little bit of what they're sharing, right? So person one is holding the little question set and reading those questions out loud. You might come to one or two where you're reading it twice because it's a longer question, okay? After we do that, we'll go into round two and we'll repeat this, or we'll just kind of trade the question pad, and person two will become the interviewer, okay? Adjust this if necessary with a group of three. How many do we have?
We only have one.
We only have one group of three, okay? So we'll work that out. And then person one is the person with their birthday coming up next. In case you're having trouble deciding who gets to do this. If you want to volunteer, different way of figuring that out. If you don't want to share your birthday. And just make sure you're going to be all hear each other, okay?
Yeah, because if you haven't even done a lesson yet, not that you don't have
On your lesson?
Whichever you want. That's
that's the problem. I did 3.31, but I did it like yeah, so we did different things. So I gave them, It is kind of nice, especially when they're bookended by two algebra ones from humanity. I have about maybe 25. That's fine. Well, here's the thing. It was originally two classes, one of 16, one of 9, and then they combined the two classes, and I lost 3 kids. So when I say maybe 25, that's what I mean. It's literally, if you put 16 and 9 together, you would have 25. And I lost 3. So it has about 22 kids. And they're all they've had me as a teacher for the past 3 years. So they really, I know them, they know me. Yes. And the ones who haven't had me since classroom teaching, I've been in the school with them for the past I wasn't getting
kids that didn't do it, maybe are
I don't get enough time to
some of the kids actually came together on their own. And then the next class, how we make everybody's come up with strong answers without okay, so kids brought up what they wanted to do. I remember that. How do you say they from
Can you make 6
Yeah, that's a harder one. On the other hand, like companies have
So I think it's this has been the easiest symbolic application than the one that
So we're not forced to use no, I have all of my other friends I don't have to here or using that. And then you say this is okay, great, I have at least in some ways a follow. But then, like then I'm struggling. I can only imagine yeah, we want the kids I have a locker for them. So if I'm not assigned
which equally dark, no, which is more orange. All right, so did you use the form of yourself or do that yourself, or was it a way?
My normal. One of the
So why did you do that?
Sometimes my questions are a lot. So based on a that's the one